Come to the next question, that is the power electronics. What is the power electronics? You know the electronics is a branch of semiconductor. Okay, you know the electronics is a branch of semiconductor. Electronics is a branch of semiconductor where we are using very small chips, small devices to control the current, to amplify the signal, to communicate between the transmitter and receiver with the help of semiconductor. We are doing only with the help of semiconductors, because nowadays semiconductors are very useful. Without semiconductor, lot of things you are unable to do, because your mobile phone is also made up of semiconductor devices. Okay, the main purpose of semiconductor to control current, amplify signals. Okay, communication devices, we are using the semiconductor. But what is the power electronics? Power electronics is also branch of a semiconductor and electronics. Okay, but what is the main difference is there? It is used in a various power transmission. Okay, it is used in a high voltage and high current. Okay, we are using the power electronics in the high voltage and high current, and we are converting here into different signal in a high power and high current. So the conversion is performed the semiconductor. We are using here in the power electronics like power transistor. We are using power MOSFET, IGBTs. I will explain everything: MOSFET, IGBT, transistor. What are these all things? I will explain everything one by one. Okay. So what in a power electronics is a branch of electronics where it deals with a high voltage and high current, and with the help of power transistor, MOSFETs and IGBTs, we make a power electronic system. Okay, and there are various type of converters. Application of the power electronics where there are various type of converters which we are making with the help of power electronics equipments. Okay, so AC DC converter is there, and a lot of things. AC DC rectifier is there, inverter is there, DC DC converter, AC converter. Basically we are using in high power transmissions. Okay, power electronics, high power transmission, high voltage, high current we are using. And for semiconductor it deal with the low voltage, low current. So you can understand it very well. Okay, move to the next question. Two reefer compressor, one stopped but another did not stop. Okay, this case will happen sometime. Let's suppose you are working in a vessel and suddenly two reefer compressor, one stop and another one did not start. So what will you do? First of all, you don't do anything. You just first go there and check the power is there on the compressor or not, because let's suppose another compressor will not start. But how you can know the power is going to the compressor or not? So you have to first check the power. To check the fuses, if power is okay, check the fuse. Power is not okay, then check the fuses. Maybe there will be fuse will be burned, there will be circuit breaker trip. If anything happen can there, there will be loose connection due to this taking high current and trip the circuit. So you have to first check that one. After that you check the electrical cables. If everything is okay, then you check the start capacitor of the compressor fan. Okay, so you just check the start capacitor for the sign of overheating. If the capacitor is damaged, you have to change the capacitor, otherwise it will start working. Then check the refrigerant level is okay or not, because due to the less refrigerant, low pressure suction cutoff is there and it will not start. Your compressor will not start. Then check the expansion valve also. Check the expansion valve are adjusted correctly. These are the case. Basically this is the important one. High pressure switch, low pressure. There may be high pressure switch also. Due to this your cooling water temperature will be high, and due to this discharge pressure will increase and high pressure cutout will be there, and due to this also compressor not started sometime. Okay, so you have to check this one also. Solenoid valve also you just check activated or not. Overcharging also sometime cause. So these are the basically checks you have to do. Okay, integral controller, I already told you, it basically removes the offset. I just explained you just little bit before. It basically removes the offset, whatever the offset I already explained you before. 3 degree is the error. So just they remove this error. Let's suppose 2 degree, 1 degree, they just remove this offset up to 3 degree. This is the basically sum of the past error plus present error of the steady state error. So okay, and let's move to the another question. What is the dynamic resistance of a diode? So dynamic resistance, I will explain you static resistance also, because sometimes they are asking this dynamic resistance and static resistance. So dynamic resistance, let's suppose this is your diode. Okay, this is your diode, and you are connecting with the AC supply, and here is the diode which we are connecting with the DC supply. Generally semiconductor device we are controlling with the DC supply, okay, but here we are supplying with the AC also. For dynamic resistance we are connecting this with the AC. So there will be some voltage drop in the diode due to this depletion barrier. There is some voltage drop and current flowing from this circuit, and the resistance, which is change in voltage and change in resistance, is given our dynamic resistance. The dynamic resistance is what? Change in a voltage, change in a current. Because we are connecting with AC supply, it's continuously fluctuating. Then we are talking like this: change in a voltage divided by change in a current. It means whatever the voltage they are changing and whatever the current is changing, the ratio of the change in voltage and ratio of the change in current gives us dynamic resistance. But here what will happen in the DC supply? Resistance is equal to voltage by current, but here constant voltage is there and resistance is also current is also constant. Okay, so the ratio of the voltage and current in a diode when connected with the DC supply, it's giving us the static resistance, that us give static resistance. Okay, and this one when connected with the DC supply will give the dynamic resistance. It means diode when connected with the AC supply gives the dynamic resistance, and the diode when connected with the AC supply gives the static resistance. And the resistance you already know is voltage by current, but in AC there is a change in voltage, change in a current, but in DC fixed voltage by fixed current. Okay, so this is the basically dynamic resistance of a diode. Then another question is 3 laws on which induction motor works. Basically 3 laws we are following in the induction motor for a proper working of induction motor. I will explain you the working of induction motor in previous lecture, so I will not explain in detail. 3 laws, what are the laws? We use the electromagnetic induction, Faraday's law. Because of this, EMF will be induced, and the induced EMF will oppose the cause, because you already know whatever the thing is keep in rest, it want to always be in rest, it does not want any change. But whenever there is a EMF induced, due to this there is a always oppose, there will be a current which always oppose, and this current is basically denoted by this Lenz law in negative sign. Due to this negative line, Lenz law always oppose the cause, because whatever the cause, because EMF is induced, they don't want to create this EMF, so that's why they start opposing. This is done by the Lenz law. And whatever the force is generating, it means the two magnetic field, because the motor, when I will just explain you, this is the motor, okay, this is the motor. When you give 3-phase supply to the stator, what will happen? Rotating magnetic field will produce, and this rotating magnetic field cut the rotor conductor, produce EMF. Due to this, induce current will induce in the rotor. Okay, because rotor will short circuited via the end rings. Induced current will create a secondary magnetic field, and when this magnetic field, primary magnetic field plus secondary magnetic field interact with each other, due to this a force will act on this, and that force is Lorentz force law. I already explained you also, when a current carrying conductor plays in a magnetic field, it always experiences a force, that is the Lorentz force law. Okay, so now I already explained you the working also, how the induction motor is working. When this force will act, then torque will generate and rotor start rotating. It means motor start rotating and produce the mechanical energy. So I already explained you in very simple language. So now let's go to the on which law, the core laws of the transformer work. Basically core laws and copper laws, these are the two primary laws, core laws and copper laws. Okay. Core laws having the two component, hysteresis laws and eddy current law. Core laws and iron laws is same, no, because some people are confusing. Core laws, basically why we are talking core laws, because of the material. We are using the ferrite material here, That's why we are telling core loss. And iron loss, there is a iron material is there, only difference is this iron material. Okay, so there are the basically two losses, core loss basically hysteresis loss, eddy current loss. Okay, I already explained before also hysteresis loss and eddy current loss, but I will just explain little bit. Okay, so hysteresis loss, I already explained what is hysteresis loss, core loss. Basically here on which law core loss transformer work. Okay, two phenomena is there, hysteresis loss and eddy current loss. Okay, these are the basically two phenomena. And hysteresis loss, why they occur? Due to the magnetization and demagnetization of the core when AC supply is given to a transformer. Let's suppose your transformer is connected with the AC supply and core material of the transformer is there, and when we connect the AC supply, due to the positive and negative cycle of AC, there is always a magnetization and demagnetization, because there is magnetic field is created, and due to the positive and negative cycle it magnetized and demagnetized, because the magnetic domain always change this position for positive and negative half, and due to this magnetization and demagnetization of the core will occur. That's why this loss is occur, that is called hysteresis loss. And eddy current, I already explained you, when a current flowing through a closed loop, when there is a closed loop and current flowing through a closed loop, then due to this eddy current formation is there, and due to this eddy current loss will be there. So eddy current loss is there. Okay, I already explained you everything. Now next move on to the another question. What is the use of brush in alternator? What is the use of the brush in alternator? Brush we are using, why I already explained in my part 2 video. Just go and watch there. The construction of the AC generator, DC generator, working of there, why we are using slip ring, why we are using the commutator, everything we are already explained in the part 2 video. So go and watch the part 2 video. But here I will just explain. Brush is basically we are using to supply the current via brush to the rotor we are supplying the current from the external source. So with the help of brush we just feed the current to the rotor circuit. Okay, so what is the difference between the brush and brushless alternator? So brushes we are using in generally alternators before also, and now some days also we are using the brushes we are using. Brushes allow the flow of DC excitation current from the external source, because we need the DC excitation in the alternator to produce a rotating magnetic field. So that's why we are providing a DC excitation with the help of brush. Okay, but in a modern alternator, now brushless alternator already come. Here we remove these slip rings and brushes, carbon brushes. Okay, we remove this one, we offset this one, and now without the alternator is coming with a brushless alternator. And what are the benefits? Low maintenance, high efficiency, no need to always change the carbon brushes, no need to clean the slip rings and all this, we don't have to do anything. Okay, so these are the things. Next question is, what are the MSB safety of alternators? For safety I will make a separate video for all the safety, main switchboard safety, auxiliary engine safeties, generator safeties, boiler safeties, whatever the safeties, whatever the machineries, I will explain, crane safeties, everything I will explain in a separate video. Okay, so lead acid battery working, this is also a long topic, I will not explain here. I will just go with the maintenance plan and all this. Working I will explain later. Maintenance, charging, and what will happen if the level goes down and density goes up. Okay, so lead acid battery I will not explain. Maintenance, just always we have to check the electrolyte level and specific gravity. With specific gravity full load 1.285, this is the specific gravity, and when the specific gravity falls to 1.110, it means your battery is in discharge condition. We have to charge the electrolyte, we have to charge the battery already charged, but specific gravity cannot maintain, so we have to fill with the distilled water also. Okay, checking the terminal also, always we have to check the terminal, inspecting for the damage, if there is any damage or not. Charging a lead acid battery, we have to properly charge a lead acid battery. There are the various charges, are the charges method is there. Trickle charging, basically we are using in emergency battery supplies, emergency power supply, because we always want to maintain full voltage, because we are supplying what in trickle charging, what we are doing trickle charging, we supply low current to maintain a battery voltage, to low current to maintain battery voltage. Okay, to maintain battery voltage, to maintain a battery voltage, so that if any emergencies occur, so battery our continuously charged and in full condition, we can directly use the battery without any delay. Okay, so this is the main purpose of the trickle charging. Float charging, basically we are using in another method. Here we are providing a constant voltage we are providing. Float charging is there, constant voltage charging method, but this is not good because we are overcharging the battery sometime also, and due to this efficiency of the battery is reduced. So somebody ask you also what is trickle charging and float charging. Trickle charging is basically current control charging. We are providing very low current for maintaining the battery charge, battery capacity in full charge, and float charging basically we are providing a constant voltage to maintain the battery, and when there is a discharge in a battery, then they again start charging the battery and maintain the constant voltage, and due to this overcharging sometime also happen. Due to this battery efficiency and battery will damage. Okay, so I already explained float charging, trickle charging. I already effect of the electrolytic level I already explained. You have to maintain the specific gravity you have to maintain 1.285 is the full charge. Okay, if it fall 1.110, our battery will be discharged. Okay, sometime in a hydrometer also it's showing 1100, 1285, so don't worry about this. 1.285 is similar to 1285 and 1100 is similar to 1.10. This is the condition of discharge and this is the condition of full charge. So we have to maintain the electrolyte level. We just measure the electrolyte level with the help of hydrometer. If there is any change, you have to just charge with the distilled water. Okay, you have to charge with the distilled water. Okay, so I already explained. If there is an increased electrolyte density, overcharging, you will overcharge, this will damage the battery. Okay, and there will be loss of electrolyte because most of the electrolyte will become vapor and escape hydrogen. Hydrogen oxygen will remove from the battery electrolyte, and it will go on to the atmosphere because of the too much vapor formation is there. This is also not, this reduce the electrolyte level and damage the battery because the battery plate will be exposed to the outside surrounding. Okay, so this is also battery life will shorten. Type of the rotor, what are the types of the rotor? Next question is, okay, our next question is type of the rotor and how to distinguish between both of them. Basically we are using the silent pole rotor and skew symmetric rotor, cylindrical rotor. You are talking like this. Silent pole rotor we are using in low speed. Okay, low speed purpose we are using the silent pole because pole number is increasing, and you already know key 120. Okay, wait. Okay, you already know ki ns is equal to 120 f by p. If p will increase, your speed will decrease. Okay, speed will decrease. So we are using the too much number of poles for the silent pole. Here you see 1 pole, 2 pole, 3 pole, 5 pole, 6 pole, 7 pole, 8 pole, 9 pole, like this. So many poles is there. Okay, so depend upon the pole we are just adjusting the speed, and cylindrical rotor are the using for the fast motors, because where we want high speed motors, and then there then that time we are using this cylindrical rotors. Okay, that time we are using the cylindrical rotors. So two type of rotor I already explained. High voltage switchboard safety I already explained later. I will explain later. Transistor Y basis thin. So move on to the next question. Okay, so now move on to the next question. Our next question is transistor Y base is made thin. So first of all, you know what is the base in the transistor and what is emitter and what is collector. Okay, so I will just explain you here. This is a transistor where we sandwiched a p-type semiconductor into two type of n-type of semiconductor. Here n is the semiconductor, n is a n-type semiconductor. And why we are calling is n? Because here number of electron is more. Electron are in majority charge carriers and holes are minority charge carrier. And in p-type semiconductor, holes are majority charge carrier and electron are minority charge carrier. But when we sandwich this p-type of semiconductor between two n-type of semiconductor, then that time a transistor is formed. And what will happen for transistor proper biasing? What we are doing? We just keep this transistor, it means this base emitter junction we are putting in the forward bias, okay, because here you see negative terminal is connected with the negative side and side of this transistor, so and positive is connected with the positive side, so it means this area is a forward bias and this area is a reverse bias. Here you see the reverse biasing, N side is connected with the positive side, it means opposite polarity is there, it's in reverse biasing. So when we do the reverse biasing, depletion width, this is width is increasing, but when we do the forward biasing, this width is decreasing, okay, this will decrease and collapse, okay. So basically for biasing we are doing this, and we have to maintain a Q point also. For proper biasing, what we are doing, we have to maintain base emitter junction forward bias proper, and collector emitter junction reverse biasing, and maintain Q point. Q point, it means stability point, we are talking stability point. If these three condition met, our transistor is proper biased, okay, then we are doing control, we are controlling the current here easily, okay. So what will the question ask, why if the base is thin, what will happen? I already explained, if this base is thin, so most of the electron will directly go onto the collector side and recombine, and then current will start flow, okay. Because if base is less and less thin, if let's suppose this is the base is 10 mm or whatever the thickness is there, if base is less, okay, if the base is less, then electron can directly jump from this side to this side, from emitter to collector, it can directly jump, and more electron recombination will be there, and then more and more current will easily flow and faster switching. So it will do the faster switching, okay, faster switching will happen. Then it means whenever you just give the positive supply, this depletion will decrease, and after that this electron movement will fast, okay. Faster switching, electron movement increase, okay, electron movement increase, base will reduce. So these are the basically things if you do the base thin, okay. So I just show you here, wait. Transistor weight is a efficient charge carrier flow, I already explained, efficient charge carrier flow, reduce base current, okay, base current also reduce because the thickness of the base is reduced, so this IB will also reduce, okay, IB will also reduce, okay. And surveyor will maybe ask you what is gain, then you can told like this, the collector current divided by the base current. If less the base current, then collector this gain will increase, it means the more and more base current will less, your IC current will increase, it means this current IC current will start flowing very fast, and then due to this gain will increase, and you can amplify the signal very easily and do the faster switching also. So you can understand it very well. So effective control also, for this base will be thin, then there will be effective control also, okay. So I think you understand this concept. Let's move to the another question. What is air circuit breaker? I will explain you later, construction and all in deep. But here they ask what are the contacts. So basically there are the two contacts, and material I will just explain here. There is one arcing contact is there, and one main contact should be there. In ACB you will see there is a main contact and there is a fixed contact, and when you close the ACB or disengage the ACB, engage or disengage the ACB, what will happen? This fixed contact will always remain in a fixed position. Fixed contact will always remains at a fixed position, but what will happen? This movable contact always going to touch with the fixed contact, okay. When this touch with the fixed contact, then that time your ACB will be closed, and when when you disengage the ACB, that time this fixed movable contact will keep a distance from a fixed contact. So that is the basically the function, the fixed contact and movable contact, how they are switching I will explain you later. And the material is basically arcing contact having the silver material. Why arcing contact the silver material I will explain you. And the main contact having the copper, we are using the copper, it means the fixed contact, whatever the fixed contact we have, this one is the copper, this one is the copper, okay, this is the copper, and this one is the movable, then this is the silver. Why we are using? Because whenever you are closing the breaker na, that time due to the closing there is a very high arcing is produced due to the closing and opening of the breaker, and we have to extinguish this arc, otherwise our ACB will be damaged. So how we can extinguish? We are using the arc shoot is there. Arc shoot is there for splitting the arcs, and we are using this arcing contact as a high silver because it is high arc resistance, because it can resist with a high arc and it can survive up to a high temperature also. So that's why we are using the arcing contact as a silver material, and main fixed contact are made up of copper material. Now you can understand easily. So move on to the further question. Silent pole rotor construction, I will explain you later. Silent pole rotor construction, this is nothing, you just read this one, I don't need any other explanation. Silent pole rotor is a low speed synchronous machine, I already explained you before. It is basically used in hydroelectric generators. Okay, poles protruding outward, this type of poles are protruding outward. Here you see protruding outwards. Poles are mounted on a large diameter cylindrical steel. Here is the large diameter cylindrical steel core is there, and above this there is a poles are mounted on the cylindrical core. Okay, and we increasing the poles, number of poles by, because we have to maintain our speed, because if pole is more our speed will be slow, and we are using the less speed in the different machinery. Like in hydroelectric generator we required the less speed, so that's why we are producing this type of rotors. Okay, so rotor core material are basically made up of laminated steel. Okay, field winding are basically made up of copper, and aluminum winding are basically pole shoes. The pole shoes are open one fitted with the pole shoe to ensure uniform gap and reduce flux leakage. Okay, damper winding also sometimes produces for the this oscillation, reduce the oscillation basically here. Okay, so you understand this one. I think move on to the other question. Why turbo generator having the small size? So there the turbo generators are made up of very small size. What are the reason? Because it is very high speed motor, that's why we are using the smaller sizes. Okay, so turbo generators operate at a high speed 1500 to 3000 rpm and have a smaller size due to the cylindrical rotor, because there we are using the cylindrical, because this is a fast motor. So this is fast generator. So for fast generator we are using the cylindrical without any poles, with no poles is there. Okay, so that's why your speed will be increased. So we are using the cylindrical rotor, and high speed operation we are using, and cooling efficiency. Okay, and also the cooling mechanism is there for the turbo generator. Now move on to the another question. Induction rotor type. Okay, induction motor, basically there are the various type of rotor we are using. The squirrel cage rotor, I already told you, the cylindrical type, that is made up of cast aluminum. Basically before we are telling this induction motor as a cast aluminum motor also. Okay, so cast aluminum, actual name is a cast aluminum. So squirrel cage rotor, you already know there is a conductive material, aluminum and copper, and short circuited by the end rings forming a structure and a squirrel cage. Okay, and another also wound type rotor is there, where we are connecting the slip rings. Okay, wound type rotor, you see here there is a slip ring is there. Okay, there is a slip ring, and we are adding the external resistance, and with the help of external resistance we are varying the torque, because torque is directly proportional to the resistance. Torque is directly proportional to the resistance. If you increase the resistance, our torque will be increased. And for the high starting torque motor, we are generally make like this arrangement. We are providing the slip ring with the external resistance. So by the help of varying resistance, we increase the starting torque, and for the starting torque it will generate a starting torque. For a motor we are using in a cranes and different elevator where we need starting torque is very high. So that's why we are using the slip ring wound type rotor. Okay, you understand it very well. And there are another type of motor also, double cage induction motor also, I will explain later. So basically this type you can read here also. Conventional wound rotor, basically conventional wound rotor, the rotor has a 3-phase winding similar to the stator, connected to the slip ring mounted on a rotor shaft. A rotor having the 3-phase winding similar to the stator. It means whatever the winding having the stator, rotor also having the winding, 3-phase winding. Okay, and connected to the slip ring mounted on the rotor shaft. Basically that are the conventional wound rotor. Okay, The main feature, external resistance can be connected through slip ring by controlling the speed and improving the starting torque. Same as like this wound rotor, conventional rotor, but here in the rotor we are doing the windings also. Okay, so you can understand this. Basically these three are basically more important, and this no need